Okay, if you didn't hear it in 4.22, the Panopto videos don't seem to be loading, so I'm just gonna write these as a spare. As always with these, I encourage you to do them before and do this as a check. So for 4.41, it's a projectile is launched with a speed of v0 at an angle of theta. Derive an expression for max height h. So as always, I'm gonna make a little diagram. So we know that velocity in the y direction will equal 0 at h. So we can say vy squared is equal to v initial squared plus 2a. So we can use this equation and we can plug in the fact that it's going to go to 0. So we're going to say this is going to 0. We're going to say minus v initial squared is equal to 2a square root y. Or sorry, change in y. Now, this is in the y direction, so we actually need to replace this. Oh, totally lied. The reason I was saying this is because we are given v naught and we need to decompose. So we can say that v naught in the x direction is v naught cosine theta, and we know that it's cosine because if cosine is 0, it's going to be flat against the ground, and v naught's entirely going to be the x. And v naught sine of theta is v naught y. So now we can plug this in for the equation. So we're going to say minus, I'm actually going to bring the minus to the other side. Say v sine theta squared is equal to negative g. And we're going to say that that this is going to be change in y, which is going to be equal to h. So we can say h is equal to g. And we can solve that with part B. So I'm just gonna calculate the max heights first, and I'm just gonna split them up. So we're gonna say for 30 degrees, our h is going to be So now that we have the meters of our max height, we have to convert it to time, so that way we can convert it to x direction. Because the change in x is going to be the x velocity, because the x velocity isn't changing because there's no acceleration in the x direction, times time. So, I think this is going to be the easiest equation because you know your change in y is your h. You know that this is going to be 0 because you're at maximum height. So it's just going to be negative 1/2 a t squared. So if you rearrange for t, so if we expand that out, t is equal to, where a is g. Oh, a is g because you're saying acceleration in the y direction. So a is g. So we know that time is v naught times sine theta times g, and we just need to multiply this by v in the x direction. So I'm just going to tack it on, times vx is equal to change in x. So we can say that at 30 degrees meters. And we can do a quick logic check in our heads where we know that 45 degrees gets you the furthest x value. So as you can see, it is that. And then it's displaying symmetry where 15 degrees on either side will yield you the same x value, which is smaller than 45 degrees. So my math kind of got a little squished there at the end. You had to say that Vx naught is equal to V naught times cosine theta, which you can see in my calculator. And so it's just V squared cosine theta all over that. And that's going to be your x value. Hopefully this helped. And hopefully you got these values. Good luck, time traveler. You got this. I believe in you.